Today we're going to do some applications of quadratics, these quadratic equations that we've been learning. And what this is to do with is recognizing it's a quadratic equation or a quadratic relationship and remembering all those skills that we've used to go on and solve them. So I'm going to write down an example about a skier going down the hill. Just give me a sec. All right, so we've got the distance traveled by an accelerating skier is given by d equals 3t plus t squared. T is time in seconds. If the distance traveled was 130 meters, for how long was the skier traveling? So what we need to do is work out what relationship is our formula. It's a quadratic. We can see that because the highest power of the pronumeral is squared. So what we then have to do is look at the information given. We've got distance traveled d is 130. So d equals 130, and we can substitute that into the formula. Now, what we've got to do is solve for the time. How long is the time? So, in order to solve, we know that we need to put 0, or any quadratic that we solve has to equal 0, so we can go on and use the Null Factor Law. So I'm going to move the 130 over and make the equation 0. And I'm going to reorder our terms so that it's in our usual form, ax squared plus bx plus c. Now, let's have a look. In this case, a is 1, b is 3, c is minus 130. So because the coefficient of the pronumeral squared is 1, I can use the shortcut in order to do the factorising. But let's suppose I'd forgotten that shortcut. We take our a times our c and our b terms. So a is 1 times minus 130. So I'm looking for two numbers that multiply together to make negative 130 that when added make 3. So I'm looking at probably a 10 times 13, but I want it to be negative. So one of those has to be negative in order to make positive 3 when I add them. So it's going to be minus 10 times 13, because minus 10 add 13 makes positive 3. So there's the times. I'm messing this right up. That makes negative 130, and minus 10 add 13 makes the 3. So let's pair them off. Let's break our b term down into our two new numbers. So we get, that should be a minus 10, apologies. I'm making a right hash of this, aren't I? Minus 10t plus 13t. So there's our b term broken down to make the 3t minus 130. Now let's factorise in pairs. Well, common factor here is t. So I get t minus 10, and then the common factor here is 13. Pull out the 13 and I get t minus 10. Now we can say that t plus the 13 has a common factor of t minus 10. Using the Null Factor Law, we can solve. So let's just go t plus 13 equals 0, which means t is negative 13. Or we can say that t minus 10 is 0, so i.e. t is 10. Now we go back to the question. It says how long was the skier travelling? Well, the skier can't have been travelling negative 13 seconds because we don't have negative time. So we have to reject this answer and say because t has to be greater than 0. That's the logic, right? Our answer has to be 10. But why have we got two answers? Well, that's because this quadratic forms an entire relationship that goes from negative infinity to positive infinity. It's a model, but our model only works for positive values of time. So we need to just take a look at that. In fact, that's called the domain, but we don't study the domain in year 9. But we need to consider what values of t is our model valid for, and it's only going to be for greater than 0. So our time is 10 seconds. Therefore, the skier takes 10 seconds to travel a distance of 130 meters. Right guys, so I'm going to do a second example. When 10 is added to the square of a positive number, the result is equal to 3 times the number subtracted from twice its square. So I'm going to set up an algebraic equation. So let's look at the left-hand side first. When 10 is added to the square of a positive number, so let's let x equal that positive number. The result is equal to 3 times that number subtracted from twice its square. Okay, so twice its square, so there's its square and that's twice, and I need to take off 3 times that number. All right, what we identify here is this another quadratic. We know that because the pronumeral's highest power is 2. So I need to move it all over to one side, set it equal to 0 and solve using the null factor law. So let's move the x squared over first of all. Take away x squared leaves us with 1x squared minus 3x, and then finally subtract 10. I'm going to factorise now. Two numbers that multiply together to make the negative 10 that when added make negative 3. Well, let's look at 5 and 2. One of them has to be negative though, so it's going to be negative 5 plus 2. So use the shortcut because the coefficient of the x squared is 1. So we're using the null factor law, either x equals 5 or x plus 2 equals 0, which means x equals minus 2. Well, it says here in the question it must be a positive number, so we reject this one, and our number has to be 5. Let's verify that. Let's put 5 in there and check the left-hand side equals the right-hand side. 10 plus 5 squared is 25. So the answer here is 35 on the left-hand side. Let's check the right-hand side. Right-hand side is here. 2 times 5 squared, take away 3 times 5. We have 25 times 2 is 50, take away 15 is 35. Left-hand side equals the right-hand side, therefore we have verified that our positive number is 5. Have a great day.